Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.17. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. Now move towards the problem. Exercise problem number 2.17. Find the value of current I1 in given below figure. This is the circuit diagram of given problem. We have to find the value of current I1 inside this circuit. So without wasting time, let's proceed towards the solution. In this circuit, the only information that is provided is in the form of currents. No other parameter is specified and we have to find the value of current as well. So we will use Kirchoff's current law that is purely based on currents. This circuit includes multiple nodes, but we will focus on these two nodes only. First, we will implement KCL on this node. On this node, one current is entering that is labeled as Ix while two currents are leaving. One is 4 mA and other one is 2 mA. So write Kirchoff's current law equation for this node. Ix is entering current while 4 mA and 2 mA are leaving currents. Open the brackets. This minus will multiply with both values and both will become negative. Now this minus 4 mA and minus 2 mA will become minus 6 mA. In order to calculate the value of Ix, place minus 6 mA on the other hand side of equal. The value of Ix will be 6 mA. We have calculated the value of current Ix, so we can calculate the value of this dependent current source as well. Value of this dependent current source is 2Ix. And the value of Ix is 6 mA. So the value of this dependent current source will be 2 multiplied by 6, that is 12 mA. Now we will apply Kirchoff's current law on this node. On this node, one current is entering that is 4 mA while two currents are leaving. One is labeled as I1 and the other current is 12 mA. So write Kirchoff's current law equation for this particular node. 4 mA is entering current while 12 mA and I1 are leaving currents. Open the brackets. Minus will multiply with both values and both will become negative. Now subtract 4 mA from 12 mA and it will become minus 8 mA because larger amount of current have negative sign along with it. Place minus I1 on the other hand side of equal to make it positive and calculate its value, that is minus 8 mA. So the value of current I1 inside this circuit is minus 8 mA. This minus sign is indicating that the direction of current I1 inside the circuit should be opposite to the assumed direction of I1. So this was exercise problem number 2.17. Thank you. See you again in next video.